Hello, everybody. This is Professor Kim. We are going to do some more exercise on Chapter 9. Um, Chapter 9 is about the having a hypothesis um, testing. To do that, the purpose of doing that is to either keep the population mean or change the or update the population mean. You want to test that. That's why they call hypothesis test, just in case we hypothesize the change of the need to change of the population mean that you have. To do that, as I said before, that you need 4 steps of proving it. Okay, you have to show the four steps. Number one, you have to state null and alternate hypothesis, and also indicate that this you need to do a left tail test or right tail test or two tail test. And then step 2, you need to compute sample test statistics, which means getting a z-value. And this is for define H0 and H1. And you have to define the p-value in our class by using the table number 3 or table number 4 from the z-value you got. Okay, p-value. Meanwhile, from the z-value, you get probability first. And then make the probability to, or convert the probability into proper p-value. And then you compare the p-value with alpha, which is the level of significance. And if that's true, then we do not reject original statement or original mean values, population mean value. So those are the 4 steps that we're supposed to follow it. Okay, so now let's look at some of the questions we have. I'm going to start from number 3, which is the easiest. But before we do that, we have to know what the condition is that they given first. So according to the condition in here, they said national average. Since it's national average, we assume that this is the population mean. So mu is 12.5. Okay. And what other information do we have? We have we are using n as 21. So from there, you got n become 21. And also we have a sample mean, which we use as x bar, is 17.1. Okay, so those are the conditions they gave us, and we have to use them throughout the questions of this particular conditions. Okay, now, and from the condition, I make it as a 1, 2, 3 different type of question. We are not going to do all 3 at the when they ask for the question. The question usually comes with a 1 of the conditions, but I just wrote down 3 to compare the difference between the questions. So we are going to do number 3 first, because that's easiest for me to do it. Now, beside the condition they gave us, which again, mu is 12.5, n is 21, x is 17.1. So I'm going to write that down in here. Mu is 12.5. Okay, 12.5, and n equals 21, and x bar equals 17.5. Okay, I'm going to write that condition down first, and then start analyzing what the question is asking for. Here, the population standard deviation, which is sigma is 10, and also here set alpha is 0.03. Okay. So those are the two other conditions they gave you. And then they say, do the data, if we have this condition, do the data indicate the mean is smaller than 12.5 or not? So this last sentence is the possible that you're updating or not. Okay, and they are saying it's a smaller. So smaller means less than 12.5. So whenever you have a less, we are using a left-tailed test. So knowing all of this, okay, we're going to start. So what's the step one? Step one that we are doing is we are defining and make a statement for H1 and H0 and H1. So H0 colon is original the mean population means, which is, so mu was 12.5. Now you want to test, you want to hypothesize that, hey, mu is supposed to be smaller than 12.5. So, oh, I made a mistake here. It's not bigger. It should be smaller. Okay, smaller than 12.5. I hope you guys caught this before me. Okay, so anyway, so H1 is saying that mu is less than 12.5, so that you have to indicate that you are going to use left tailed test. We're going to use left tailed test at step 3. Okay. Okay. Now, step number 2, you have to compute or calculate the z-value. We call computer statistics. The z-value formula they gave us when sigma is known was x bar minus mu divided by sigma divided by square root of n. So I'm going to use this particular formula for this particular question. So x bar was given as a 17.5 minus mu is 12.5. And sigma was 10 and n was 21. So it was square root of 21. So when I do that, 17.5 minus 12.5 is 5. 10 divided by square root of 21 is whatever that I don't have a calculator with me. And then you get almost 2.11 as a z-value. Okay. So 2.11 as a z-value. So when you do that, now you have to go to step 3. Step 3 is going to the table with a z-value 2.11 and find the probabilities. So 2.11 in z-value, in this particular case, 2.11, where is the 2.11? .11 is here. First 2.1, and you look for 1. That's what when it's probability, when it is 2.11. Okay, so 2.1 and 1, you get this value, 0.9826. So probability become 0.9826. So now going back to original, hey, probability of when z is less than or equal to 2.11 is 0.9826. Okay, so you got the probability. Now, if you use the left tail test, the p-value equals to probability. So p-value becomes 0.9826. And then step 4, you're comparing this p-value. So if is p-value bigger than level of significant. So let's see, p-value was 0.9826. Is this bigger than 0.03, they said? So if you're not quite sure, that you can look at the number line. So number line here is a 0. Here is a 0.01 and 0.02 and 0.03. So your level of significance is here. And then far away, here is a 0.9826. So this is bigger than 0.03. So yes. So when the p-value is bigger than alpha, if it's yes, then we do not reject h of 0. We keep the h of 0. So that's the final conclusion for step number 4. So this is how you do 4 steps for this particular question. So we are doing this because they are hypothesized that the mean is smaller than 12.5. So what if it's bigger than 12.5, like number 2? So if it's bigger than the mean is bigger than 12.5, so that means they are hypothesizing that the mu is bigger than 12.5. So when you have a bigger, we do right tail test. So we are doing right tail test. So knowing that, if we do 4 steps to prove either they are bigger than 12.5 or not, the step 1, you make a statement of h of 0 and h of 1. So h of 0 is that mu is 12.5. And they are questioning in h of 1, mu is supposed to be bigger than 12.5. Okay? And we're going to use right-tailed test. That's step 3. Okay? That's step number 1. Now, step number 2 is calculating the z values. So again, the z value become x bar minus mu over sigma divided by square root of n. So 17.5 minus 12.5 over 10 divided by square root of 21. We did this calculation already, so that's about 2.11 again. Okay. And step 3, you have to find the probability by using g value is 2.11. Okay. Actually, the g value is in this case bigger than 2.11. So what we're going to do is, first we're going to find the probability at g is 2.11. So when we go back to table number 3 at 2.11, again, you get 0.9826. Okay, 0.9826. So that's a 0.9826. But the thing is that the p-value that you're looking for, when you have a bigger than, you have to say 1 minus z is p of z is less than equal to 2.11. Okay? Because you have to do a right tail test. When you have a right tail test, this is always 1 minus left tail test. Then you will get the right side. So that's why you have to do 1 minus p of z is less than 2.11, which means this is a 1 minus of 0.9826, because that's what we got. So when you do that, you end up with 0.0174. So that's the p-value that you have. So at step 4, now, so comparison between these two is, this is a probability, and this is p-value. Okay? And so step 4, you are testing is p-value that you got bigger than alpha. So let's see, 0.0174, is that bigger than alpha, which is 0.03? Okay. So when you make a number line, now here is a 0.01, here is a 0.02, here is 0.03. So you're comparing that 0.03 and 0.0174 is a little after the 0.01. So is this bigger than 0.03? No. 0.03 is far away from 0, so it's no. So when it's not, then we do reject. Because if it's yes, it's do not reject. Since it's no, we do reject h of 0 and keep h of 1 statement as new population means. Okay, so that's how you prove the hypothesis testing by using this 4 step. Okay. Now, what if you have different than 12.5? So like number 1, they are asking the population mean is different from 12.5. So mathematically, what that means is that mu is not equal to 12.5. So when you have this not equal to, you have to do a two-tailed test at step number 3, I mean. Okay. So step 1, again, you have to make a statement that h of 0 colon that mu is 12.5, and then h of 1 saying that, hey, mu is different now, 12.5. Can I do the hypothesis test? Okay, you can do that, but you have to specify here that you're going to do two-tailed test at step number 3. Okay, so that's what the step number 1 is. Now, step 2, you have to calculate the z-value. So z-value become x bar minus mu over sigma divided by square root of n, and we got this as a 2.11 from previous questions. And then probability of the z-value when z-value is less than or equal to 2.11 was, again, the one that you got, 0.9826. Okay? That's the probability. Now you have to get a p-values. So p-value for the two-tailed test is always that 2 times 1 minus probability of when z is less than or equal to 2.11. So when you do that, it becomes 2 times of 1 minus 0.9826, which is 2 times of the result of 1 minus 0.926, which is 0.0174, right? 0.0174. So that end up with 2 of that become 0.0348. 0.0348. So that's the p-value after you do a two-tailed test. Now, that was step 2, and it was a step 3, getting a p-value. Now, step 4, you have to test it. So if p-value actually is p-value bigger than alpha, okay? So again, 0.0348, is that bigger than 0.03? So when you do the number line, yes, it is. So yes, it is bigger. So when they are bigger, we do not reject h of 0. So that become our final conclusion for this particular case. Okay. So that's how you prove 3 different type of hypothesis test. So let's do one more set. Okay. Now in second set, they are saying that in the condition first, national average. So since it's national average, we assuming this is mu. So from there, we found the mu equal to 0.5. And then again, sample is again 21. And sample mean, not the population mean, was x bar, right? It's at 17.1. And then they are asking either 3 different type, okay? So again, I'm going to do the easiest one first, smaller. So when mu is smaller than 12.5, you do left-tailed test. So step 1, you have to make a statement for H0 and H1 and use the colon and define mu was 12.5, and you want to check that either this is a lesser than 12.5. So you want to do hypothesis test on this, which is left-tailed test. So that was a step 1. And step 2, you have to find the z-value again. So z-value is x bar minus mu over sigma divided by square root of n. So 17.5 minus 12.5 divided by 10 over square root of 21. So when you do this, you will probably get 2.11 again. Okay, so we are doing same thing, but I'm showing you the same steps. So that's the Z value. So now in step 3, you have to find the p-value. So before the p-value, you have to convert the z-value into probabilities. So when you do that, you go to table number 3. And 2.11 is 0.9826. Okay. Now here comes the problem. I supposed to do this way only when you have sigma is given. But in here, I forgot, I jumped it. But do we have a sigma here? Sigma is given. When here we said sample standard deviation is 10, this is not a sigma, this is S. S is given, so S is 10. So that means I cannot use this formula. So your step 2 changes. In step number 2, we call T value. T value is x bar minus mu divided by S, divided by square root of A. So when you do that, okay, in this particular question only, you will have the same answer anyway, because S was same as 10. So you got 2.11. So which was a T value now. So when you have a T value, use table number 4, not number 3. Okay, so you mean it's not 2.11? No, it's not. So, okay, let's go and see how you find the probability when we use a table number 4. But before you do that, not only we need a 2.11, you need something called degree of freedom, which is the comma f. That's always n minus 1. So since it's n is 21, 21 minus 1 is 20. So you need 2.11, and you need degree of freedom. Okay. So what else do you need? Well, if you go to table number 4, you need a degree of freedom, which is 20. You need the and what else do you need? Well, we said z value was 2.11. Okay. So from degree of freedom values, you have 0.687, you have a 1.185, and on and on and on. You have to see where 2.11 belongs to in this table. 2.11 belongs to between these two value. It's between 2.086 and 2.528. Then your range of the probability when you have a left tail test, which means one tail test, here is a one tail area, is this. So your probability become lesser than bigger number, which is 0.025, and bigger than smaller number. So number has been switched, 0.01. So your probability when t or z value is that, then that become your new probability in range. So when you do a z value and p value, you get one p-value, one probability. But when you have to find from the table number 4, you don't get a one value, you get a range of the value. So is p-value becomes 0.01 between 0.01 to 0.025. So here now you have to say in step 3, the p-value or range of p-value is between 0.01, 0.025. Okay, so notice that you're gonna get into a range. So that was a little different than when sigma is given. Okay, so now step 4 again, they are exactly same. Is range of the p-value bigger than alpha or not? Okay, so let's see, is range 0.01, p-value 0.025, is that bigger than 0.03? So if you look at the number line, here is a 0.01, here is a 0.02, here is 0.03. So 0.03 is here. So that's the level of significance. And range of the p-value of the entire thing was somewhere between here. Okay. So all of this is that bigger than 0.03? Okay. Well, no. All of this is smaller than 0.03. Okay. So since it's no, what happened? We do reject h of 0 and keep h of 1 as a new value. Okay. So do you see the difference now? Okay, it does not difference until step 2, but when you find a range of the p-value, it changes. Okay, and instead of the left tail, right tail, left tail, right tail, we make it as a one tail, and two tail system as a two tail. Okay, so now let's look at another question. Number 2, again, in city A, sample standard deviation is 10. Oh, so S is 10 again here. So S is 10. And alpha is 0.01. So what is step 1 now? The step 1, and also they say bigger than 12.5. So since mu is bigger than 12.5, this is right tailed test, which means one tail test on table number 4. So step 1, you define h of 0 colon mu was 12.5. And h of 1, mu is bigger than 12.5. So that's right tail test. Which is one tail test. At step number 3. Okay. Now step number 2. You have to define the t value, right? So same as z, but t value is x bar minus mu. And instead of sigma, because sigma is not given for whatever the reason, you use s instead of it, which is a sample standard deviation. So s equal to 21. You get almost 2.11 again. Okay. And then you need this, and you need degree of freedom, which is n minus 1, which is 21 minus 1 as a 20. So you need this 2 value to find the probability, actually range of probability in this case for step number 3. So if you at step number 3, the range of probability, now if you go back to the table, you got 2.11, you got degree of freedom as a 20, and 2.11 is between here, going all the way up. You got the same range of a probability. Now going back, the p become less than 0.025 and bigger than 0.01. That's the range that you got, because this is a one-tailed test area. Now at step number 4, okay, again you do the same thing, okay. Is p-value, range of p-value bigger than alpha or not? So you compare that. So range of p-value is 0.01 with bigger than 0.01 and less than 0.025. Is that bigger than alpha? In this case, alpha was 0.01. So when I use the number line 0.01, 0.02, 0.03, 0.01 was here, right? And range was from here to here. So which one is bigger? Is range bigger than 0.01? Yes. Yes, it is. So what happened? We do not reject h of 0, this case. Okay, we keep h of 0 as the still population mean. Okay, so now how about different then? So mu is different than 12.5 in this case. So that's two-tailed test. So knowing that, again, step number 1, you make a statement that h of 0 colon mu is equal to 12.5. H of 1, mu is not equal to 12.5. So in here, you use two-tailed test. Step 2, you have to calculate the t-value. So again, t-value is x bar minus mu of s divided by square root of 10. When you do that, you get about 2.11 again. Okay, so when you go back to table number 4, this case and degree of freedom was what? 21 minus 1, which is 20. So this value and this value, you need that. So 20 with 2.11. Only difference is when you go up, you settle with a two-tailed area. in this case, two-tailed area. So probability of two-tailed is between, P is between 0.05, so bigger than 0.02 and less than 0.05. Okay, here. Bigger than 0.02, less than 0.05. So that's two-tailed area for range of the probability, 0.02 to 0.05. So now here in step 3, range of probability, the P become 0.02 to 0.05. So step 4, we are testing is range of probability we call p-value bigger than alpha 1. So that's p-value in two-tailed area. So is 0.02 to 0.05 bigger than equal to alpha, which is 0.01 here. So if I make a number line, here is 0.01, here is 0.02, 0.03, 0.04, 0.05. So here is level of significant and range from here to there. So is this range bigger than level of significant, 0.01? So yes, it is. Okay. Yes, it is. So what you do is, yes. So when they are bigger, what do? We do not reject, right? So we do not reject h of 0. We keep h of 0. So this is a third type when you have, when the sigma is not given, but S is given, okay? So I hope you learn. This is complicated, but with many practice, you can get this, okay? So I will see you in our regular class. Please study this. Thank you. Have a good day.